The next integration technique that we need to know for the A-level course is by parts. The formula is luckily given in the formula book, however you do need to understand how to use it. What we're looking for is an integral which has two parts multiplied together. The answer to that integral will be a multiplication of two functions minus another integral. So if you like integration, by parts is great because you get two integrals for the price of one. Although the formula is in the formula book, only in OCR and OCR MEI does it actually say it's by parts, so you do have to recognize that this is the by parts formula in itself. If you're lazy like me, you can also use this formula here, which uses fewer letters. Because the formula has two functions multiplied together inside the integral, that gives us an indication of the type of things that we're going to be integrating using this formula. Any product of two functions like these is going to require the by parts formula. I'll now show the proof of where this formula comes from. If you are squeamish about proofs, please skip ahead. So if we want to use the product rule, it says that the derivative of the product of uv will be u times by the derivative of v plus v times by the derivative of u. You can write that in the dv dx notation as well, but I'll be lazy. Now, if we integrate both sides, then we're going to get the integral of the first thing is equal to the integral of the second thing plus the integral of the third thing. I'm splitting across the integral here. You could write it in two steps if you wanted. Now, what's the integral of a derivative? Well, because integration is anti-differentiation, we'll just be left with uv. And now if I write this again, you might see where the proof is heading, because the integral of uv dash, if we rearrange, will be uv take away the integral of vu dash. Okay, let's look at an example. So the first one, we want to integrate x e to the 2x. We see it's an x multiplied by an e to the 2x. So we're going to be using the by parts formula. So we need a u, and dv dx, again, I'm going to call it v dash. And we need to find what u dash is and what v is. For this one, I'm going to do it in order. I'm going to say u is x, and I'm going to say v dash is e to the 2x. I will explain a bit later on how you know which one to choose. If we go through the motions, what is the derivative of u? The derivative of x is just 1. What is v? We're not differentiating, we're integrating. So we need to integrate e to the 2x. If you're not as sure about that, check out my previous video. To integrate e to the 2x, we divide by the coefficient of x and then leave e to the 2x as it is. Now we follow the formula. This integral will be equal to these two times together, 1/2 x e to the 2x minus the integral of the bottom two. So 1 times by this will just be 1/2 e to the 2x dx. We now continue by doing the second integral. The integral of e to the 2x is the same as over here. That's not changed, but it's times by another half now. So in total it's 1/4 e to the 2x plus c. Let's see what's in store in example 2. In example 2, we want to integrate 3x sine 3x. In the same way, we set up our u, and we set up our derivative of v. I'm going to let u be 3x, and I'm going to let the v dash be sine 3x. What's the derivative of 3x? Well, that's just 3. What's the integral of sine 3x? Well, that's minus 1/3 cos 3x. And again, if you're not confident with the integral of sine 3x, watch my previous integral video. Let's now use the formula and see what we get. We're going to times these two together. So minus 3 times a third cancels out. X cos 3x minus the integral of these two. 3 times a third again cancels out. We're going to get minus cos 3x dx. The first term's not going to change, but we're now trying to integrate this. I'm going to do one more step just to simplify the two minuses there, like this. So instead of minusing the minus, we're going to add the integral of cos x. The integral of cos 3x is 1/3 sine 3x. And then plus c. So our final answer is minus x cos 3x plus 1/3 sine 3x plus c. A question that often arises is who's u and who's v dash, and does it actually matter? Well, to show you it does, I'm going to swap it round. Instead of making u x, I'm going to make u e to the x, and I'm going to make the derivative of v x. What's the derivative of e to the x? That's still e to the x, it's never changing. What's the integral of x? It's going to be x squared divided by 2. Now if we use the formula, let's see what we get. We get 1/2 x squared e to the x minus the integral of these bottom two, that's 1/2 x squared e to the x. Do you notice that that integral has got harder than the first one? That's why the order matters. What we're looking for is, we want the u to be something that when you differentiate it, it gets simpler. So x differentiates to a constant which is simpler. But e to the x stays as e to the x, it's just as tricky. To help us out, there is an acronym that we can use, which is LATE. Hopefully not such a tricky word for some of you to remember. This stands for logarithms, algebra, trig, and exponentials. And what we'd like is that the u letter is as far to the left as possible. The reason is the logarithms are quite easy to differentiate, but up until now we don't actually know how to integrate them. V dash will be the other one, whatever's left over. Worst comes to worst, if you forget the acronym, try it one way, and if it doesn't work, then swap it round and try it the other way. Let's put that into action with example 3. We're integrating 2x ln x. Have a think about what do you think will be u and what do you think will be v dash. What's going to be nice to differentiate and make it simpler, or what's going to be difficult to integrate, which will make it harder. What do you think? In this case, we're going to do u is ln x and v dash is 2x. The reason is the derivative of ln x is 1/x, but we don't yet know the integral of ln x, so we can't make it v dash. We would never find v. In this case, v is the integral of 2x, which is x squared. Let's use the formula. We're going to do these two, which is x squared ln x minus the integral of these two times together. X squared times 1/x is simply x. Let's do a further integral. What's the integral of x? Hopefully you know this by now. half x squared plus c. Well, I don't seem to be able to shut up about the integral of ln x, so let's solve the integral. I'm telling you it's by parts as a hint, although it doesn't look like it because there's only one function. So can you think of what you could add into the integral that won't change it, which could turn it into two functions multiplied together? Well, we could write it as the integral of ln x times by 1. It's now a product of two things, and we've not changed anything. And in this case, what will u be? What will v dash be? U will be ln x. If we made it v dash, then we wouldn't need to answer the question because we'd have v. So we make u ln x, v dash must be 1. The derivative of the natural log is 1 over x, and the integral of 1 is x. Yes, when we integrate 1, it makes it more complicated, but it will simplify down with the derivative of the ln x quite nicely. So let's use the formula. We're going to do uv, which is x ln x, minus the integral of these two times together, which is 1. You couldn't ask for a nicer integral. So the final answer will be x ln x minus x plus c. Right, your go. I would like you to find the integral of root x ln x. Let me know when you're ready and I'll give you the solution. Ready? Okay. In this case, u is going to be ln x and v dash is going to be the square root of x. The reason is that the ln is the logarithm and the root x is the algebra. Next, you would differentiate the u dash and you would integrate this. This isn't in the nicest form, so we have to turn it into x to the half before we can integrate it. But then we add 1 to the power and divide by the new power. Then you will have used the formula. So we get this is equal to 2/3 x to the 3 over 2 ln x minus the integral of 1 over x times by this. Well, you're dividing by x, so you're subtracting 1 from the power. So minus 2/3 x to the 1/2, which looks like a pretty good integral to me. So after this step, you will have integrated that. You will have added 1 to the power again, divided by the new power to hopefully get this as your final answer. Did you get it? You could also get some questions like this, where you may have to use by parts twice. So an integration by parts, or by parts, depending on how you want to say it. We're trying to integrate x squared e to the 2x, and you notice as soon as you start using the formula, why you're going to have to do it again. What's u going to be in this case? X squared. What about u dash? 2x. V dash then must be e to the 2x, and then what's the integral of e to the 2x? 1/2 e to the 2x. The formula's there, let's use it. X squared times by 1/2 e to the 2x minus these two times together, so 2 times 1/2 is 1, so we're just going to have x e to the 2x. And you might be sat there thinking, well, this thing, I don't know, not off the top of my head. Looks like another by parts, and it is. So what I'm going to do is I'm going to change to a different colour, and I'm going to set out the new by parts question. What's u going to be in the new integral? Just x. V dash will be exactly the same. U dash will be 1, and v, the integral, will still be 1/2 e to the 2x. Now if we try and put that all together, we'll get that this integral bit is 1/2 x e to the 2x minus the integral of 1 times this, which is 1/2 e to the 2x. So to put that all together, we've got 1/2 x squared e to the 2x minus the integral of this, which is what's in green, So I'll pop that in over here. Just enough room. We know what the integral of a half e to the 2x is. That should be a quarter e to the 2x. Minus a quarter e to the 2x. And then the only thing left to do is expand that bracket. The final answer will be a half x squared e to the 2x minus a half x e to the 2x plus a quarter e to the 2x plus c. Not so bad, eh? Now back to your turn. I would like you to integrate 2x squared sine x over 2. I'll give you a bit of time, pause now, and I'll write the solution when you're ready. In this case, u will be 2x squared and v dash will be sine x over 2. That means that u dash will be 4x and v will be minus 2 cos x over 2. Using the formula, we'll get minus 4x squared cos x over 2 minus the integral of minus 8x cos x over 2 dx, which will equal minus 4x squared cos x over 2 plus 8 lots of the integral of x cos x over 2 dx. That's another by parts, lucky you. In the new by parts, u will be x, u dash will be 1. V dash will be cos x over 2, and v will be 2 sine x over 2. Therefore, we'll get minus 4 x squared cos x over 2 plus 8 lots of 2x sine x over 2 minus the integral of 2 sine x over 2 dx, which will simplify to minus 4x squared cos x over 2 plus 16x sine x over 2. The integral of 2 sine x over 2 will be minus 4 cos x over 2, which if we simplify that with the minus and times it by 8, we should get plus 32 cos x over 2 plus c. Foof. Well, there you have it. That's how you integrate by parts. I hope to see you in the next one where we integrate by substitution.